My name is Tobias. You can call me Toby. We're all friends here now. I just want to manage expectations. I have nothing to do with the magic under this shroud. So if that's what you're here for, I'll give you a minute to file out. Be quiet, please. Otherwise, I'm just going to jump right in. I'm going to start by giving you a very, very quick overview of what my organization does, because we're a bit of an outlier at this amazing conference. And then I'll describe an important societal mystery that we're trying to disentangle through the use of GPT-4 and some very old yet information-rich texts. So Development Data Lab is a social research nonprofit that aims to do two things. First, make it easy for people to use data to answer critical societal and economic development questions, primarily but not exclusively in India. We mainly achieve this through maintaining comparatively large, clean, open data sets and a little bit of OSS. And two, to conduct our own careful analysis to answer important societal and economic development questions. So think research papers plus data journalism and policy briefs. So in short, you can think of us as kind of a combo of an academic research lab and a bit of a tech startup. Here's a quick but representative example of some of our research work, which explores the question of whether major infrastructure investments actually improve people's lives. There have been billions of dollars invested in India's canals network, but it still remains very difficult to say whether it was in fact a good investment. You need robust causal analysis and data from many sources that is carefully integrated together. This is a zoomed in shot illustrating the empirical strategy, which is not at all important for this talk, but I thought it was a nice visual illustration of the necessity of both data interoperability and large sample sizes to reach a robust conclusion. Each little dot represents the centroid of a single village in India. The blue lines are the canal network, while the purple blobs are the command areas served by those canals. But today, my talk is going to focus on how we're applying LLMs to a really significant social problem. India is a confusing outlier on patriarchy. It's getting rich, but women are still secluded in the household and barely working. India has a female labor force participation rate of 25%, compared to about 70% in North America and 60% in sub-Saharan Africa. So India has the largest number of working age women who are not in the workforce in the world. Social norms are generally considered to play a significant role in the lack of female empowerment, but that role is contested and difficult to disentangle, let alone quantify. So we need to understand which social groups have changed their norms around women's status and, importantly, why they have done so. So does urbanization reduce the restrictiveness of a community's gender norms? What about whether or not you live in a desegregated residential neighborhood where you have greater exposure to more and different points of view? These questions aren't revolutionary, but there has been a big problem in answering them. Virtually all ethnographic tabular data is static and based on recent surveys, making it impossible to understand these important social dynamics and, importantly, how they're changing. So, if only we could learn what things were like in the pre-modern era, then we could examine why change is or largely is not occurring and why. There is some good machine-readable data going back as far as the 1990s, but we need to go back much further in order to answer our patriarchy riddle. Enter the British colonial administrators. They collected information on Indian tribes and castes for governance and strategic planning and for more nefarious purposes, namely divide and rule. There are thousands of castes in India with tons of heterogeneity and cultural norms, and the texts from the British Raj era include details related to origins, historical lineage, social structures, customs, inheritance, many other categories. And these were all published in a series of long-form volumes between the 1880s to the 1930s. Critically, there is a ton of information focusing on marriage and other highly pertinent gender norms. So these texts became our target. We estimated that extracting all norms across all books manually using data entry services at Indian rates, and we found it would cost many tens of thousands of dollars plus a great deal of additional engineering and manual verification work to validate the result. So while these data are highly desirable from an analytical point of view, accessing them historically has been cost prohibitive. The GPT-based approach that we're using and that I'm going to talk about, we estimate will, at the end of the day, cost us between $5,000 and $10,000. So at least an order of magnitude of cost savings compared to our outside option. Here are some sample excerpts from the texts highlighting marriage norms and a little bit of dietary norms there as well in the background. Notice a couple of things. First, there is significant formatting heterogeneity with inset subheadings and annotations and other idiosyncrasies. Second, the heavy use of special characters with a wide range of diacritics. And third, differences in image quality. And indeed, I spared you the worst images. Needless to say, there was quite a range. Each of these elements caused annoyances at both the OCR and the querying stages. We had to incorporate the handling of OCR errors into our prompt engineering, which ended up working pretty well. The fundamentals of our basic workflow are to first OCR the images into machine-readable text, then to chunk into community-level descriptions, then to run our queries to formalize the norm variables. We OCR'd about 50,000 PDF pages through a Tesseract-based workflow, which gave us decent outcomes. We've since experimented with Claude 3 Sonnet, which was very promising out of the box, so we'll probably rerun the OCR, at least for the most difficult subset of our corpus. The chunking step involves identifying and partitioning text for about 5,000 subcasts. And I have our friend the Mechanical Turk up there because we ended up doing this manually rather than taking a RAG approach, and I'll tell you why in the next slide. And lastly, we then ask questions of about 30 classes of social norms, yielding both categorical responses, usually yes, no, or no information, as well as returning all relevant text excerpts for all communities. And that's where I'll focus the remainder of the talk. Briefly back to the RAG issue, this slide shows how we went about manually marking up community names within the OCR text. The markup allows us to chunk and extract community name lists that we then feed into the API calls in addition to the relevant chunk. I don't expect you to read this, just notice these special markup lines. We ended up creating an Emacs minor mode to make it very easy to insert these, in addition to a couple other flavors of markup like identifying hierarchical relationships between groups and subgroups, and excluding chunks of text that we didn't want, like output from images in most tables. We decided to take this approach instead of using RAG because the manual chunking technique ended up being reasonably quick. It was deterministic, importantly, and very accurate. And from my point of view, being able to cut out that entire area of complexity at relatively minimal implementation cost made going manually the right move in this case for us. After creating community-wise chunks of the corpus, we needed to engineer our prompts and our validation methods. We had a range of knobs and tools to play around with here, but one of the primary ones was the use of this kind of JSON blob. I definitely do not need you to read this. I bet that many, if not most of you, are very familiar with function calling with the OpenAI API. This allows us to specify the format that ChatGPT delivers its response. And importantly for our case, it allowed us to partition the categorical or binary encoding of the norm. So for example, right of primogeniture equals true from the captured excerpts, the sentences that are relevant to that norm that led the model to make its decision. The function call gives us another way to tailor our prompts towards our desired response in addition to the system message and the prompt input. This is an example response from the API. It does what we want as far as providing both a categorical encoding of the norm and a compilation of the text excerpts in separate fields. The JSON structure makes it incredibly easy for us to integrate the output into our post-processing workflow, which generates the tabular data, runs a variety of validation data quality checks, and ultimately merges to data from the 90s to create a panel spanning over 100 years. Early results have been quite promising. These queries were run on GPT-4 and checked against manually encoded norms across 3 of the books. You can see the overall accuracy rate is about 95%. I expect this number to go up by the time we finish, but we believe this to be an acceptable amount of noise for our purposes. Crucially, GPT did well not only on the encoding, but also on returning all of the relevant text excerpts. This is really important for us because it allows us to go back ex post if at the analytical stage we realize the construction of some of our norms variables needs to be tweaked. We've already got all of the relevant text extracted from the larger corpus. We can just go back and reanalyze those or rerun a different query without having to query the entire corpus again. I consider this error rate to be conservative. Some of the encodings that we marked as incorrect here really were a judgment call that a human might have struggled with as well, particularly one without a ton of domain knowledge. Unfortunately, not to bury the lead, I don't have results from the full corpus to share with you today yet. We're going to do the full run within about a month from now. But we have already started identifying the composition of caste groups within neighborhoods, which we know to be quite segregated, illustrated by this map here. So we'll be able to readily tease apart the link between increasing liberalization of gender norms and how people are spatially arranged relative to each other. So really, GPT is finally giving us enough resolution and temporal coverage to really hope that we'll be able to clearly elucidate the role that cultural norms play in female empowerment for the first time. And we hope to identify both the causal pathways as well as the obstacles for India, which has remained stubbornly behind despite truly extraordinary economic growth trajectory. Whoops. Okay, so our next steps here really center on how we validate the model output, which can be simplified into 3 buckets. First, we're scaling out our confusion matrix by enlarging our library of manually constructed tests for specific community, norm, and book combinations. This is really like the most trustworthy component of our testing framework. We're also augmenting these manually defined tests with synthetic data, just because the manual ones are extremely expensive, even though they're the most reliable. Next, we're implementing a response evaluation model to focus on the internal consistency between the excerpts as well as the encoded norms variables returned by the function call. So the basic idea is use a different LLM to spot check the first LLM. In our case, the response evaluation model is essentially just replicating human evaluation paradigms and then scaling them. We don't expect this to be as comprehensive and trustworthy as the manual suite of tests, but it very easily scales, which obviously is essential. And lastly, we're experimenting with developing a confidence score that could help us to flag ambiguity in interpreting the raw text, which we would then go and manually review. So like I was alluding to on the slide with the confusion matrix, there are a lot of cases where the actual written text doesn't super unambiguously conform to like a single interpretation of a norm. And if we can find a way to programmatically elevate those cases of ambiguity and bring them up for a pair of human eyes to look at and easily do that, like that's a huge win for us. So ultimately, the aim of this project is to completely open source the panel data set when we're done with it, because there are many more analyses that should be done, and analyses of really significant social importance than we could do, or frankly, we could even think of. One of the most rewarding parts of my work is seeing what the broader community is able to do with the data that we put out into the world, even if it means that other people find our bugs. Just kidding, I love a good bug report. So where do we go from here, given what we've learned? We think that these techniques will generalize very well to additional data sets that will help us answer more important but historically intractable questions. So, for example, how much does urbanization and internal migration to cities determine upward mobility? How does zoning and other regulation affect growth and human outcomes in cities? How biased is the judicial system? To what extent are major polluters causing morbidity and mortality as well as exacerbating climate change? Some of the most socially important questions in developing countries are limited by reliable data. Historical data, yes, but also more recent data that are difficult to access through traditional methods. We've already begun processing the written decision text from 80 million court cases from the Indian lower courts. This will, which like our norms data, this is also from PDF files. And with the help of LLMs, the content of these written decisions will allow us to finally understand urban development. Am I out of time? No, this is, okay, I'm almost done. Yeah, it's going to really help us elevate our understanding of urban development, judicial bias, political influence in the judiciary, well enough to really to continue to push for more evidence-based policy. And we're just spinning up a big effort to partner with private data companies to leverage their proprietary data assets for the public good to help answer some of these questions that simply can't be solved with public data sources alone. So that's it. Thank you so much for including me in this awesome track. I would be happy to talk with anyone afterwards or just connect with me virtually ex post. Thank you very much.